Hello everyone. So I'm trying out a new way of recording class. I think this is going to go much better than my recording a notebook. So today's special edition of Sunday Review for your quiz begins now. All right, so let's start with this problem. Suppose you have a rhombus of side length S. At what angle is the area maximized? So just so that you guys can remember, a rhombus is a quadrilateral where every side is the same length. And so I'm going to decide to make this angle theta. So what we want is to maximize the area, comma, A. And so by adjusting theta, okay? So we want to change this shape, like, oh, that's not what I want. I'm still figuring out this app, but whatever. We want to change the shape such that we get a maximum area. So we want to change that theta. And so maybe it's going to be more up and down. Maybe it's going to be more stretched out. We don't know, but we just want to see what happens with this function. Okay. First, we want to figure out how to calculate the area of a rhombus. You could look this up on Google, or we could just play with this a little bit. And so I'm just making some up and down sides here. And so we've got two right triangles and we have a rectangle in the middle. And we have this theta, and I'm going to make this h here. So I want to point out that we have these two right triangles. They are the exact same size, and we have the rectangle in the middle. And so if we were to split this up a little bit, this might be some distance L right here. So L is from here to here, which means this is L from here to here. And then this distance right here is going to be S minus L. So if we were to find the area, then we would end up with area is equal to the two triangles. So that's 2 times 1/2 L times H plus this guy, which is H times S minus L. Okay, so with this, we have 1, 2, 3 variables, and none of them are theta. So we want to get it down so that we only have theta, and maybe S, because is S changing? No, S is a constant. So we want to write L and H in terms of theta and S. So S is a constant. Okay, S is a constant. And so first, let's look at this L right here. So I'm going to do point. Look at this L. And we have this theta is the same angle as over here. And so L is going to be cosine, or this L, let's look on the side. So L is right next to our theta, and then our hypotenuse is S. So it turns out L is equal to, oh wait, no, that's not what I want. Let me erase that. Erase! All right, and then draw. So cosine of theta is equal to L over S, which means L is equal to S times cosine of theta. All right, and then similarly, we can do this for H. So H is going to be equal to S times sine of theta. So if we go back up here, we have that our area is equal to 2 times 1/2 is just 1, and you have L times H, and so you have S squared cosine of theta, sine of theta, plus H, which is S sine of theta, times s minus, I think I need to move this over a little bit. So let me select that. And move. Okay, s times, or s minus, and then we're subtracting L. And so that's s cosine of theta. Okay. So if we go on, I'm going to the next page. We can see that we have that a is equal to s squared cosine theta sine theta plus s sine theta, to all times s minus s cosine theta. And then we can clean that up, and eventually we end up with a equals s squared times sine theta. Now remember, s is a constant. And so we can treat it the same way you would treat like the number 5. And so remember, we're trying to maximize this area. So we will take the derivative. So the derivative of sine theta is cosine theta. So we're going to end up with the derivative is s squared cosine theta. Okay, cool. And so we set this equal to 0. So 0 is equal to s squared cosine theta. Divide by s squared. And so 0 is equal to cosine theta. Therefore, the zeros of cosine are pi over 2 or 90 degrees, 3 pi over 2, 5 pi over 2, etc. But the only answer that makes sense here is pi over 2, because pi over 2 is 90 degrees, whereas 3 pi over 2 is 270 degrees. And so our answer that makes sense for this problem is pi over 2. And so we want to check and make sure that this is a maximum. So I'm going to use the second derivative test. And so for this, we're going to do a double prime. And then the second derivative, so the first derivative is this guy right here. And so this, second derivative, or again, s squared is a constant. So we have the second derivative is s squared times negative sine of theta. So you get a negative s squared sine of theta. And so we need to check at pi over 2. And so when you check at pi over 2, you get negative s squared sine of pi over 2. And sine of pi over 2 is 1. And so this is going to be equal to negative s squared. S is a positive number. Therefore, this is a negative number, which means our second derivative is a negative number. It's concave down, and we have it's a maximum. All right. So that is this first problem that we worked through. All right, here is our second problem. So a fish is reeled in at a rate of 1 foot per second from a point 10 feet above the water. At what rate is the angle between the line and the water changing when there is a total of 25 feet of line out? So we've got a rate here. So let's underline this. So we're looking for a rate, or we're given a rate, and we're asked for a rate. So this is a related rates problem. So related rates problem. And so I'm going to go in and I'm going to label some things here. We have that the top of the fishing pole is 10 feet up. We have, this is the angle we're looking at, theta. And our distance of our line we're going to say is x. So when we're looking at this, the things that are changing is x and theta. Again, only notice the things that are changing. Don't notice the rates that are changing. The things that are staying the same, so not changing, is going to be that 10 feet. 10 feet. A number we're ignoring for right now is the 25 foot, because the 25 foot has to do with this value here of this x. And so that is changing, so you do not want to put a number to it. But let's start by relating our x and our theta. And so our equation that we want to work with for right now is we have x and theta, and so and a right triangle. We have this right triangle right here. And so for a right triangle, we usually have the Pythagorean theorem. We have similarities if you've got like embedded triangles, but we also have trig functions. So if we're looking at this, I think a trig function is the best because we have an angle. And so we have the 10-foot, which is the opposite, and we have x, which is our hypotenuse. And so let's say that for opposite over hypotenuse, that's sine. And so we have that sine of theta is equal to 10 over x. So if we want to take the derivative, I'm going to rewrite this, and I'm going to say it's x sine theta is equal to 10, just because I like that better before I take the derivative. I'm going to go to the next page. So we have x sine theta is equal to 10, and we want to take the derivative with respect to time because it's a related rates. So we have x and we have sine theta, and so we have two factors, which means we're going to need to use the product rule. And so the derivative of x is dx dt sine theta plus x times, and then the derivative of sine is cosine theta, but we need to multiply by d theta dt because we are using implicit differentiation to solve this, is equal to 0, So now we are looking for, on the previous page, we are looking for the rate that the angle is changing. So our goal is d theta dt. And so I'm going to underline that. This is our goal. But we need to find x, theta, and d theta dt. Oh, wait, sorry, dx dt. Let me undo that real quick. Dx dt before we can find d theta dt. And we are given some of this information in our problem. And so at what rate of 1 foot per second from a point, so that is going to be how x is changing. So dx dt is 1. And he's reeling it in, and so it's actually minus 1 foot per second, I believe. Let me go back and check. So it's reeled in. So this distance x is shrinking. So our rate is negative. Okay, from a point 10 feet above the water, at what rate is the angle between the line and the water changing when there is a total of 25 feet? So x is 25 feet. So x is 25 feet. So we still need to find theta. And so if we look at our triangle and draw it again, we have 10, we have 25, and we have theta. So we can use sine to solve for this. So we have sine of theta is equal to 10 over 25. So theta is equal to arc sine, or sine inverse, of 10 over 25. Okay, so I'm just going to write this here. You could type that into your calculator and get an approximation, but this is fine as far as a number goes. And so whenever I plug this in, we get dx dt is minus 1, so that's negative. Sine of theta, which is sine, and then theta is arc sine of 10 over 25. Plus, and I'm going to go down, I don't have enough space, so plus 25 cosine of arc sine of 10 over 25, arc sine of 10 over 25, times d theta dt is equal to 0. Okay, so this is really, really nice. These guys, remember, arc sine, you take a ratio and you get an angle. And then sine, you take in an angle and you get a ratio. So these guys are going to cancel out. And so when we, oh, there's a dog. Okay. So we end up with negative 10 over 25 plus 25. And then for cosine of arc sine of 10 over 25, then you're going to end up with cosine of, we could actually solve for this using the Pythagorean theorem. So I'm going to pause real quick. All right, so I solved for the side A by using the Pythagorean theorem. here, and we get that a is equal to the square root of 525. So if we're looking at the cosine of theta, it's going to be the square root of 525 over 25. So let's zoom back out and move on over. And so that's going to be 25 times let me change colors. Times the square root of 525 over 25 times d theta dt is equal to 0. Here, the 25s are going to cancel. And so you end up with, I'm going to add this 10 over 25 or negative 10 over 25 to the other side. And so you get root 525 times d theta dt is equal to 10 over 25. And so d theta dt is equal to 10 over 25 times root 525. And then our units are going to be radians per, and I don't remember what the time is. It looks per second. So this is our ultimate answer, not cleaned up. So I think this is an appropriate answer. If you wanted to, you could put this into your calculator and approximate it, but I'm just going to leave it as is. Leave it as is. So just going back to our problem, we're looking at how this theta is changing, and we solved for that just using basically sine of theta. So we found something that related the two things that we knew the rates of. So the line in the water and the angle. And then rewrote it in a way where I liked how it was written, though we could have kept it in this form and took the derivative. And then we took the derivative with respect to time. Solved for everything that was unknown. Plugged it into the derivative we took with respect to time, and then just finished. And made sure to put in units and then messed with a little bit of extra geometry going forward. Next, we're going to do just a classic implicit differentiation. So we're going to solve for dy dx of the equation x squared times y squared equals tangent of y plus x cubed. So first I want you to notice that you have x squared times y squared. So we're going to need to use the product rule. And so you have 2x times y squared plus, and now we leave x squared alone, and we take the derivative of y squared, so that's going to be 2y times dy dx. So anytime you take the derivative of a variable that is not your bottom variable here, you need to use implicit differentiation. And then derivative of tangent of y is secant squared of y. And again, times dy dx, plus, and then derivative of x squared is just, or x cubed is just 3x squared. So there's our derivative. And now we just want to get our dy dx on its own. And so I'm going to subtract, let's say I'm going to subtract this to the other side, and I'm going to subtract this to the other side. So I'm going to get the dy dx's on the right. And so we've got 2xy squared minus 3x squared equals secant squared of y dy dx minus 2x squared y dy dx. And then I'm going to factor out that dy dx. So dy dx, and so you have secant squared of y minus 2x squared y. And then I divide. I divide by that thing to get dy dx on its own. And so you have 2x y squared minus 3x squared all over secant squared of y minus 2x squared y is equal to dy dx. And then that is it for that type of a problem. All right, I want to leave off with just some general facts about first derivatives and second derivatives. So real quick, if the first derivative is positive, then your original function is increasing. If your first derivative is negative, then your original function is decreasing. Hey, Hillary, you left the door open. It's not closed all the way. And then if you wanted to find a max or a min, remember, first you find where f prime is equal to 0 or does not exist. And then to check, actually this is called a critical point. Remember, whenever you have this set up, if you have f prime is equal to 0 or the first derivative does not exist, that is a critical point and it is just an x value. It is not the y value. And then you want to check if it's a max and min either by using this. So use your first derivative to see is it increasing then decreasing, or is it decreasing then increasing. So you want to check points around your critical point in order to discover if it's a maximum or min, or to confirm it is. And then the other information you might have is second derivative. So if your second derivative is positive, then you have your original function is concave up. And remember, it could be just a piece of a smile. And then if your second derivative is negative, then your original function is concave down. And remember, you could just have pieces. You don't have the full frown. And then you can use this. I don't like that. Let me delete that. And let's get this green. So you could use this as well to determine if it's a max or min. You don't have to do both. You only have to do one. And then the last thing I want to talk about is if your second derivative is equal to 0 and the second derivative changes signs, so it goes from plus to minus or minus to plus, then x comma y is an inflection point. Okay, it's an inflection point, and that is a full point. So at x, if the second derivative is 0, and to the left and to the right it changes from concave up to concave down or the other way around, then this point is an inflection point. And remember, a max or a min is the y value. So critical point is the x value, a maximum or minimum is a y value, and then a inflection point is the x and the y value. Yeah, so I think that's everything I wanted to do, like a quick review. I wanted you to have another related rates problem, another optimization, and then just general stuff. So you might be asked with like this page in particular, over what intervals is your function increasing? So you're going to want to use the first derivative to do that. What are your critical points? What are your inflection points? Over what intervals is the function concave up? And so you just have to use this information in a wise manner. And then later today, be watching. I will post the cheat sheet. Not cheat sheet. It's not really a cheat sheet. But I will end up posting. So later Sunday, because this is being put up on Sunday, I will be posting the help sheet, which you are allowed to use on your quiz. Okay? You are not allowed anything else. So you can't go Googling how to solve something. You can't ask your brother or your dad or your sister or your mom or your neighbor how to solve anything. And you most definitely can't work together with other people in the class. This is replacing tests. So we want to see what you can do. Again, you will have 50 minutes to do it, plus 15 minutes to upload it. So I told you on my Friday video how I want you to do the quiz. So if you don't know, go back to the Friday video and look that up. But just know that you are on a time limit and it starts when your class starts. So it will become available at either 1:30 or 2:30 depending on which class you are in. And then what else? I will not have a lecture on Monday, like a normal lecture. I will do a remind you video Monday morning, but also I'm going to be available on Zoom from 11:15 to 11:45 a.m. as well as my normal 3:30 to 4 p.m. on Monday. Again, this will not be useful for doing the quiz because your quiz will be done by then. However, this will be useful. So this one will be useful for quiz questions because your quiz won't have come out yet. So yeah, that's when I'll be available on Monday. So cool. And that's it. A heart for you.